All right, Wildcats, page 134, Chapter 4, Lesson 1, Mountain Building. Okay, let's get our paper set up. Name, class, and Monday's date, November 16th, 2020. Topic or objective, science, FNT, phase 4, summarize, capital SUMMARIZE. So we're going to be moving on to the part where we summarize. Phase 1, take notes. Phase 2, process by highlighting and annotating the key details that support the main idea. Phase 3, something I know, also something I predict, or something I wonder. You have to choose one of those. And then phase 4 is the summarize, where we write the paragraph. Now, I've been doing the paragraph with your help, but this is where we move on and you write the paragraph all by yourself. Okay, this entire lesson is called Mountain Building. In blue, Mountain Building. Main idea / EQ. Mountains form from plate motions. Mountains, MOUNTAINS, form, FORM, from, FROM. Wait, did I say that right? Form, FORM, from, FROM. See how it switches them? Form from plate, PLATE, motions, MOTIONS. Mountains form from plate motions. Okay, red, folding and faulting forces. Oh wait, vocabulary. Oops, vocabulary. Vocabulary. Dome mountain. DOME. Mountain, MOUNTAIN. Page 136. That's going to be the next page. Dome mountain. A dome mountain is a dome-shaped mound that forms in Earth's crust. Here's a picture. Dome mountains form when volcanic material bulges upward under the crust, hardening as it cools. So basically you get this giant bubble of magma pushing up underneath the ground. But it doesn't break through and create a volcano. It just kind of creates this bulge. So that is the magma that cooled millions of years ago. And all the other stuff around it weathered and eroded away, leaving behind that bulge of hardened magma. So let's see. Dome, DOME, dash shaped, SHAPED. Dome shaped mound, MOUND. Let's say hardened magma. Indent, hardened, HARDENED, magma, MAGMA. Let's draw a little picture like that, right? So let's make a little bulge of magma, MAGMA, and then let's draw the layers of the earth showing that dome-shaped mountain. There. And let's make the bulge go up a little bit higher. There we go. Okay, the next vocabulary term, fault block mountain. Okay, dome mountain, right there, fault, FAULT dash block, BLOCK, MTN period is the abbreviation for mountain. Fault block mountain, page 135. This is 135. A fault block mountain is a mountain that forms from a block of crust that is pushed upward or downward along a fault. That's what this looks like. So something's getting pushed up, and next to it, it's not getting pushed up as fast, or it might even be getting pushed down, and you end up with cliffs. Okay, so block of crust, BLOCK, of crust, CRUST, pushed, PUSHED, indent up or down. Okay, let's draw a little picture. I'm going to draw this little squiggly line going up like that, and there's a cliff. And then right about there, I'm going to draw that. That could be getting pushed up, or that could be going down. And let's kind of draw a second line right there so we can see that that's the fault, F-A-U-L-T. So over here, you usually end up with cliffs, C-L-I-F-F-S, arrow, cliffs. Next one, fold mountain, F-O-L-D-M-T-N period, fold mountain. There's the fold mountain right there. A fold mountain forms where continental plates collide, causing the crust to fold and crumple. Okay. Plates, P-L-A-T-E-S, collide, C-O-L-L-I-D-E, arrow, fold, F-O-L-D, slash crumple, C-R-U-M-P-L-E, crumple. Let's draw a picture of that. Okay, I'm going to try to draw that little line down the middle. And then the big wavy lines like that. And a big wavy line like that. And then kind of like these sinusoidal waves inside here. And an arrow coming together. And an arrow coming together. So when the plates collide, sometimes you'll get some subduction, but at the top surface, at the very top of the crust, you'll also get folding and crumpling to create fold mountains. Okay, hot spot, H-O-T-S-P-O-T. No, that's not Wi-Fi. Hot spot. Going backwards, magma plumes rising from the mantle create hot spots under some areas of the crust. So rising, R-I-S-I-N-G, plume, P-L-U-M-E, of O-F, magma, M-A-G-M-A. Guess what? Right here for the dome mountain, that is a hot spot. So let's go up there and put H-O-T-S-P-O-T, hotspot. That's a magma hotspot. That's a magma hotspot. Okay, the last one, volcano. Oh, I think we know what that is. V-O-L-C-A-N-O. I think that's it, right? Volcano. Now, on page 136, it's the plural volcanoes, so there's an E. Volcanoes are mountains formed by magma that escaped from Earth's interior, then cooled. Okay, so a volcano is kind of like a hot spot that bursts through the crust. Let's see. Magma, M-A-G-M-A, escapes, E-S-C-A-P-E-S, interior, I-N-T-E-R-I-O-R. So squiggle line, H-O-T-S-P-O-T. It's kind of like a hot spot, but it bursts out. So let's draw the little magma hot spot that we had earlier. But then let's keep going up and up and up. And then we'll draw a line down to the left and a line down to the right. And now the arrow's coming up out for the volcanic eruption. E-R-U-P-T-I-O-N, eruption. Here's the magma down here, M-A-G-M-A. There we go. So if a hot spot is hot enough and strong enough, it can escape the Earth's interior and erupt out to form a volcano. All right, there's a lot to do this week. This is a busy, thick, dense, heavy chapter. So let's get to it. Folding and faulting forces. Folding, capital F-O-L-D-I-N-G, and down 3 down. Faulting, F-A-U-L-T-I-N-G, forces, capital F-O-R-C-E-S. Mountains are Earth's tallest landforms. Some reach several kilometers above Earth's surface. Ranges such as Asia's Himalayas and California's Sierra Nevada form huge barriers, hundreds of kilometers long. Okay, so mountains, mountains, can be kilometers tall, km for kilometers tall, slash 100s for hundreds kilometers long, long. So km is the abbreviation for kilometers. Remember, kilometers are a little bit shorter than miles. Even with modern roads and bridges, mountains can be difficult to cross. Because mountains are so huge, you might think they are permanent, but that is not so. Just like Earth's other surface features, mountains are continually being created and destroyed. The actions of tectonic plates build up mountains, while weathering and erosion wear them down. Okay, so plates, P-L-A-T-E-S, build up, B-U-I-L-D, up, but weathering, W-E-A-T-H-E-R-I-N-G, slash erosion, E-R-O-S-I-O-N, tear, T-E-A-R, down, D-O-W-N. So plates build mountains up, but weathering and erosion tears them down. Mountains are constantly changing. They are not permanent. Scientists classify mountains into 5 basic types: folded, fault block, volcanic, dome, and erosion mountains. You will learn about each type in this lesson. Okay, let's see. Do they have subheadings? No, but they do mention them and draw pictures, so we'll do that as we go. You will learn about each type in this lesson. Most mountains form at or near plate boundaries, especially those where 2 plates push together. In these zones, fold mountains are common. A fold mountain forms where continental plates collide, causing the crust to fold and crumple. Over time, erosion wears down and softens the folds. That is why some of the oldest fold mountains, such as Arkansas's, I have no idea how to say that, Ouachita Mountains, have rounded peaks. Okay, so fold mountains. We have fold mountains here. We know the plates collide and they fold and crumple. We know that they're pushing together because we drew that. We know that continental plates are colliding. Let's see, erosion wears down and softens the folds. Okay. So weathering and erosion can tear down mountains or indent, soften, S-O-F-T-E-N, folds, F-O-L-D-S, slash peaks. So if the mountains look kind of round and a little bit shorter rather than tall and craggy and sharp, then they're getting softened by weathering and erosion. Okay, let's see. In other cases, stress on the crust causes it to crack instead of fold. This creates faults or fractures in the crust. Fault block mountains may form wherever faulting occurs. A fault block mountain is a mountain that forms from a block of crust that is pushed upward or downward along a fault. Okay, so here they get pushed together and they fold and crumple. Well, imagine all of this crust was very hard and brittle. As they push together, instead of folding and crumpling together, they're going to start cracking and popping and lifting. And you're going to get something like this, or you're going to get pieces like this. Think of like peanut brittle that you get at Christmas time, and how it cracks and crumbles and splits, rather than something softer, folding and mushing together. Okay, so let's draw something like that. The fault block mountain, we drew the cracks. Okay, let's say that. Stress causes cracks. Stress, S-T-R-E-S-S. We're up here at fault block mountain. Stress, arrow, cracks. C-R-A-C-K-S. In most cases, fault block mountains form when stress splits the crust. Okay, we just said that. Land on one side of the fault is raised while the other side drops downward. Okay, we have that in our picture. The Grand Teton Range in Wyoming is one example of fault block mountains. Okay. As with fold mountains, erosion helps shape fault block mountains. Here's an example here, right? You can see the cliff eroding and coming down here, almost like we used to see with alluvial fans. Older mountains have softer edges. Many of the valleys near the mountains are partly filled by material that has eroded from the nearby mountainsides. Okay, so you can see this is a pretty sharp drop right here. So this fault is pretty new, but there has been enough time for this dirt and rock to erode and weather and erode down into the corner of the valley here. In eastern and southeastern California, lines of parallel mountain ridges and valleys dominate the landscape. These ridges are blocks of land raised or lowered along fault lines. California's Death Valley is a block of land that has been dropped between parallel faults. It dropped so far that Death Valley is the lowest point in the United States. Oh, wow. Okay, let's put that in there then. The Death Valley. Capital D-E-A-T-H, capital V-A-L-L-E-Y. Let's see. Lowest point equals lowest, L-O-W-E-S-T, point, P-O-I-N-T, indent in, capital U period, capital S period. And that is because it was a fault, F-A-U-L-T, dash block, B-L-O-C-K. And if it's the lowest point, then it obviously had to drop, like that. All right, that's the entire first 2 pages. Classify. How do fold mountains form? Okay, those are fold mountains. Fold mountains form when plates collide, zoop, causing the crust to fold or crumple into mountains. There we go. That's it. We could also talk about how over time the peaks get softened or rounded by weathering, softening folds and peaks. All right, good job on the first day. Persevere with the growth mindset. Roar Wildcats.